Today's problem of the day is number of laser beams in a bank. We are given an array of strings containing ones and zeros. This 2D array represents the floor plan of a bank where 1 denotes the presence of and 0 denotes the absence of a security device in any given cell. Additionally, there is one laser beam between any two devices if they are located on two different rows, say R1 and R2, and there are no devices in all rows between R1 and R2. We are tasked with finding the total number of beams in the bank. Let's go through the first example. We are given the floor plan as a 4 by 6 matrix where the four rows contain 3, 0, 2, and 1 devices respectively. The expected output is 8. Let us understand this in detail. Going by the conditions for the formation of laser beams, we can say that beams exist between all devices in adjacent rows and in between all devices in rows separated by empty rows. Let us see what that looks like. Starting from the top, all the devices in the 0th row will be connected to all the devices in the second row because the first row is empty, which means that the device at 0, 1 will be connected to 2, 1 and 2, 3. Similarly, 0, 2 will also be connected to 2, 1 and 2, 3. Again, the device at 0, 5 will be connected to 2, 1 and 2, 3. This gives us a total of 6 beams so far. Next, all the devices in the second row will be connected to the single device in the third row. This looks something as follows, where 2, 1 is connected to 3, 2 and 2, 3 is also connected to 3, 2. This leaves us with a total of 8 beams which matches the expected output. If we try to analyze this, we can see that the 0th row contains 3 devices, the first row contains 0 devices, the second row contains 2 devices, and the third row contains 1 device. The expected output is 3 times 2 plus 2 times 1. This is true because each of the 3 devices in the 0th row will be connected to each of the 2 devices in the second row, and each of the 2 devices in the second row will be connected to the singular device in the third row. In general, we can say that for n rows, the output will be the sum of product of number of devices in adjacent rows or in rows separated by empty rows. Let's write the code for the same. We'll start by declaring ret and setting it to 0. Next, to have the sum of products of number of devices in adjacent row or in rows separated by empty rows, we must remember the number of devices in the previous non-empty row. Looking at the constraints, we see that the maximum number of devices in any row is 500. This fits in an unsigned 16-bit integer. Therefore, let's declare a uint16 underscore tpref and set it to 0. Now we can iterate over the rows, and for each row, first we have to find the count of ones. If the count is equal to 0, we will continue since we must ignore empty rows. If the count is not equal to 0, then we will add the product of the count and the number of devices in the previous non-empty row to ret. And we'll set pref to count. Once we exit out of this loop, we can simply return ret. Let's submit this. And we see that it works pretty well. If you have any questions, feel free to ask them in the comment section. Also, you'll find the link to my Leetcode solution in the description. Thank you for watching.